Hello guys, you are welcome to this lecture. Let us provide solutions to the experiment M2 of the physics practical manual. Now to begin, we are going to complete our table first and also every other thing that is particular to completing the table. So let's take the first one here. You said the time for 20 oscillations. I understood that the 20 oscillations was changed to 10 oscillations. So everything that we are going to be working with to find our period here will be 10 oscillations. Okay, now we have T1 plus, okay, sorry, not this one. This one is 20 oscillations. The 20 oscillations were maintained. Okay, the 20 oscillations were maintained. So let's work with this. Now we have T1, T2. Then they said the mean of T, which is the mean time. These are all replicate measurement. T1, which is equals to 4.38, and T2, which is equals to 40.38, and T2, which is equals to 40.51. So what we are going to do now is to get the mean, you add these two together and then divide by 2. So this will give us 40.38 plus 40.51 divided by 2. When you do this with your calculator, 40.38 plus 40.51 then divide by 2, that will give us 40.45. so this gives us 40.45. it means our mean time is 40.45. now at this point in time, the 40.45, you are going to divide it by the period, by the number of oscillations to get the period. So we can say our period TL is equal to the mean of T, the mean T divided by number of oscillation. Okay, divided by number of oscillation. So this will be equal to, what is our mean? Our mean is 40.45 divided by number of oscillation is how many? 20. So we have 40.45 divided by 20, and that gives us 2.02, which is 2.022. okay, now but in the table what we had was TL square minus TY square, TL square minus TY square. So what we are going to do now is we now say TL square here, which is equals to, it means we should square whatsoever we have here. We said this one give us 2.022. so when we square that, when we square 2.022 to get TL square, we say we square what? 2.022 rather, 2.022. so when you square that, it's going to give us 4.09, 4.091. so that is our TL square. Now we are going to complete our table. Now to complete the table, first of all we have to find the mean of everything here. Now I told you that the mean just means add T1 plus T2 divided by what? 2 will give us the mean. Then the period will be divided by number of what? Oscillation. So let's go together as we do all at once. So for the first one, we have 26.55 plus 26.35 divided by 2. Now that will give us 26.44, which is the mean, 26.44. Now to get the period, divide this 26.44 divided by 20, which is the number of oscillation. So this divided by 20 gave us 1.322. Now this 1.322 is your period. Now to find the period square, you square what you have here. So if you square what you have here, so when you square this period, it's going to give us 1.748. 1.748. Now what are you going to do? You are going to subtract, or let's leave this for the last. Then the next one is 24.63 plus 24.74. When you divide this by 2, it's going to give you 24.69. Then you are now going to divide this again by 20, which is the number of oscillation, to give you the period as 1.34. Then you are going to square this to give you 1.523. Then the next one is 30, which is 22.91 plus 22.78 divided by 2, which is 22.85 divided by 20, 1.142 squared, 1.305. So the next one is 20.79 plus 20 plus 75 divided by 2, which is 20.77. Then if you square that, 20.77 divide by 20, which will give you 1.039. Then square it, which will give 1.079. Now the next one is 18.97 plus 18.75 divided by 2, 18.86. Divide this by 20, 0.943 squared. That's 0.943. No, this 18.86 divided by 20, 0.943. Then when you square it, it's going to give you 0.889. Then the next is 16.65 or 16.98 plus 16.65 divided by 20. Divided by 2 first. That will give us 16.82. Then divide this one by 16.82. Divide this one now by 20 to give 0.841. 0.841 square is what? 0.706. Then the next one is 14.08 plus 14.04 divided by 2. It gives 14.06. And then when you divide this with 20, it's going to give 0.352. Then when you square this, it's going to give this is 0.352. 0.352. When you square that, this one gave a very low figure. Are you sure? 14.06 divided by 20. 14.06 divided by 20 is 0.703. Then squared is 0.494. Okay, now having gotten to this point, the next step now is to now go back to our TL square. Where's the value of TL square? We said TL square is what? is 0.222 squared, which gave us what? 2.022 squared, which gave us 4.091. Okay, 2.022 square. Okay, 4.09. This is supposed to be 4. Okay, it's still in line. Anyways, so when we come here now, what we are going to do is to write that value 4.091. Come here and place it anywhere around here. So we are going to say 4.091 minus any of the value you have here. This value here is what is called the ty square. So 4.091 minus each of the value here will give you this column. So let's go. This will be 4.091 minus 1.748, which gave here 2.343. Then the next one is 4.091 minus 1.523, also be 523, which gave us 2.568. The next is 4.091 minus 1.305, which gave 2.786. Then we have 4.091 minus 1.079, which gave 3.012. Then we have 4.091 minus 0.889, which gave 3.202. Then we have 4.091 minus 0.706, which gave 3.385. Then we have 4.091 minus 0.494, which gave finally 3.597. So we've completed our table. Now that we've completed our table, the next step to take is to come to plot our graph. Now the question says plot a graph of t square versus y. Plot a graph of t square versus y. Now here is supposed to be t square, here is supposed to be y rather. Plot a graph of t square versus y. Now the question answers that you should plot a graph of t square against y. So we are going to come here and say let's this one be y axis. Okay, this is t square, so we may put t square here. Then the unit is what? Second square. And then come here and put y axis here, which is this case is y, and the unit is centimeter. So you come under here and put 0, 0. Now you write the title of your graph. The title is a graph of t square against y. A graph of t square against y. Okay, that is the title of the graph. A graph of t square against y. Now you are now going to choose a suitable scale. Now your scale and your graph, your title is supposed to be on top. Like when you see your before your graph, you see a space. That's where you're supposed to write it. But because of space, I'm going to write the scale here. Now you are going to choose a suitable scale. Now my scale here may not be the same with your own. You just look at what is obtainable in your manual, and then the space available also in your graph to choose your scale, and also the values that you have in your x and y axis. So we have on the t square axis, what do we have? We have 2, 2, 2, 3, 3, and then what that. Then on the y axis, what do we have? We have 10, 15, 20, 25, 30, 35, and what? 40. So we can say let 5 centimeter represents 1 unit on the what was the graph? Okay, plot a graph of t square. So we can say let 10 cm or 1 cm represent 5 units on the x axis, and then on the y axis, which is t square, we can say let 4 centimeter represent 1 unit. Let 4 centimeter represent 1 unit, so that we have enough space to put in our value. So if 4 centimeter represent 1 unit here, it means that here will be what? 1. The next 4 centimeter, that means those your boxes, you count them 1, 2, 3. Then the next 4, that is 4 centimeter, will be what? Another unit. Then let's say 1, 2, 3. The other fourth one will be another unit, 3. And then you have your boxes 1, 2, 3, and then the fourth one here will be another one. Are we getting it now? So it continues like that till maybe 5. Then on this axis, you say let 1 centimeter represent 5 units. So our scale is let 4 cm represent 1 unit on the y axis, and then 1 centimeter represents 5 units on x axis. That would be a suitable scale. Now here will be what? Every 1 centimeter is 5, so here will be 5. Then we have 10, 15, 20, 25, 30. Where's the least here? Least here is 40, so we still continue. 35, and then finally we have what? 40. Now, having gotten this, the next thing you do now is to start your plotting. Now, what were your values? Your values, you are plotting this t square against y. So these ones are on the x axis, y axis. Why this one is on the what? X axis. So you have 2.343, and then it was 40. So when x is 40, this one is 2.43. So you come back and say 40, 2.43. Are you getting it? So we take it here. Now 2.5 is in between. Are we getting it? 2.5 is like we are counting 4 spaces, which is 1, 2, 3, 4. 2.5 is just like 2.4 is just like in the middle. Are you getting it? When you see your graph, you should be able to take the 2.5 from it. So we come here and then take it. Let's say this is our 2.5. Assumption, no, don't go and use this. You already have your graph, so you know where it should fall into. So let's say these are 2.4 in between. 2.4 should be at the third one, because if here is 1, here is 2, it means it should be somewhere around here, so that this other 2 would be half. So 2.4 should be somewhere very close to the one in between. So at this point, you mark here as one of your points. Now the next one is 2.5 and 35. So we come to 35, and then we take 2.5. 2.5 is very close to 2.4 the way it is. So we come here, mark this as our 2.5. Then the next one is 30 and 2.8. 30 and 2.8. 2.8 should be very close to 3. So we also come here and we'll mark this point. Let's say this is our 2.8. You should know where your values fall. Okay. Then the next one is 3 and 25. So we have this as our 25. Of course, we know this where our 3 is. 25 and 3. So you mark this point. Then the next one is 20 and 3.2. So we come here. This 20. Where will 3.2 be? 3.2 is somewhere around here. So we'll mark this point. Okay. Then the next one is 15 and 3.4. So these are 15. 3.4 is somewhere around there, so mark it. There we have 10 and 3.6. 10 and 3.6, which is from here. 3.6 should be somewhere around there. Maybe it's not too upward. 3.6 should be somewhere around there, so we mark it. Okay, so this is how our graph is going to look like. Now at this point in time, what you do is to now draw a straight line. Okay, let's draw the straight line and see what it is. Now this is how your graph is supposed to look like, your straight line. You discover that when I drew mine, I drew it in such a way that it started from the beginning of the graph to the end of the graph. Are we getting it? So that's what you are supposed to do to get your slope, your straight line. And then your straight line should be in between your values. Don't draw it such a way that only one part, it should be in between. That is why it's called the line of best fits. Are we getting it? But in most cases, when we are plotting graph, we just discover that some of them enter, some don't enter. Then we take the one that is also okay like that. But the ideal thing to do is to draw your straight line in such a way that it passes through the middle of all the line. That is the average. Are we getting it? That is a precise value for each of them. Because what you are trying to look at is how clustered the values are to the true value. That is the main value you are determining. That is why you are looking for your slope, to see how clustered your values are to the main value. So the best place it should be in between all your values. Are we getting it? But in most cases, it's not really like that. We always forge our way through. But that is okay, sha. So the next thing now is to take our slope. Now our slope should be big enough. But because I don't have a graph, I'm not going to take a very big slope. I will just take 2 points in the graph that I know their exact value. But if you have a graph note, you can take any point. So if I should take my slope from here, it should be a straight line and it should be big enough. Ideally, my slope, I'm supposed to take it somewhere like this and then to somewhere like this. That's supposed to be the point. But because I don't have a graph, what I'm going to do is I will take 2 points that I know inside the graph as my slope. Now, so this is my slope. I'm now going to calculate the slope. Now, most times it's not ideal that you calculate anything on your graph. But for the sake of whatsoever, I'm just going to take the slope from this point. So my slope, what you are supposed to write, and all this writing are supposed to be your worksheet. Okay? So let me just do it here. Everything you are going to write is supposed to be on your worksheet. So this thing I'm writing here, which is the slope, it will be on your worksheet. Okay? Slope is change in y axis all over what? Change in s. Now in this case, your y axis is what? Is t square. So it says change in t square all over what? Change in, what is your y axis? Change in y, which is what? T square final minus initial, but that one does not really matter. Okay, so we are going to take the 2 points from the graph now and then take them as our values. So on the t square axis, what point did we take? We took 3 points. I think that value there is 3.6 also. This last value, I think that is the last value. It's 3.6. So we say our slope will be 3.6 minus, then this point, you trace this point down and then take it. This point is about the 4th point, which is 1, 2, 3, 4, 5. Okay, the 5th point downward, which is 1, 2, 3. Okay, downward 1, 2, 3, 4, 5, which is 2.786. Is that the point? Yes, 2.78, which is 2.8. 2.8 divided by, where's your change in y? Change in y is 30 minus 10. 30 minus 10. That is the point with which is corresponded here. So when you are taking it here, you also trace it down. The point with which is corresponded here is your what? Is your values. Okay, now this is a negative slopes graph, so you are supposed to get a negative slope. It's not supposed to be 30 minus 10, but what was, when it was 3.6, what was y? I mean, what was x axis? X axis was 10. So you take this one as 10 minus, when it was 2.8, what was on our x-axis is 30. So this thing is supposed to give you a negative slope. Whenever you see a graph coming from this way to this direction, it's usually what? Negative. So at the end of the day, what are you going to have? Now, when you punch this in your calculator, it gave you 3.6 minus 2.8 is 0.8. This is supposed to be 0.8. Oh yeah, 0.8. Then divided by 10 minus 30 is what? Minus 20. So when you punch this in your calculator, what is it giving to you? Minus 0.04. Minus 0.04. So your values you are having, so your value is minus 0.04 as your slope. So the slope of this graph is minus 0.04. Are we getting it now? That is the answer to that slope. So all these should be written in your what? In your, what is it called? In your worksheet, okay? So at this point you come here and write, they say the slope of the graph is minus 0.04. Your value should be within this range. Then the intercept on the t-square axis. Now I'm going to look here. What's my intercept? Your intercept is the point at which this crosses here. Is your intercept. So you are going to trace it. Now by what I have here, my intercept is like 4.2 or 4.1. I don't know, because this is not a normal graph. Are we getting it out? So it's supposed to be around that 4.2 or 4.1. So I come here and say my intercept is 4.2, which is second square. 4.2 second square. That is the intercept. Now how about this? What would you, this would be second square per what? Centimeter. So at this point in time, what other thing do you need to do? You say derive the relationship between t square and y. I relate s and c with the physical constant of the setup. So let's do that quickly, okay? Now normally your equation for period of oscillation t is usually 2 pi root of L over G, or you can say root of what? H over G, where H is the height or the length of the thread. Now but in this case our H is equal to what? L minus Y. So in place of H we are going to put what? L minus Y. So this gives us T is 2 pi root of L minus Y divided by G. So at this point in time, what do you do? To remove this square root, you say square both sides, okay? Square both sides. So this will be equals to t square is what? If you square 2 pi, what is it going to give to you? Give you 4 pi square. Now the square will remove this from here, so we are left with what? L minus Y divided by G. Now this gives us t square is equals to, use 4 pi square to open through. It gives you 4 pi square L minus 4 pi square Y divided by, of course, sorry, let me write this up here so that to be visible enough. So this is t square is equal to 4 pi square bracket L minus Y all over G, and then t square will be equal to 4 pi square L minus 4 pi square Y divided by G. And then at the end of the day, t square will be equal to what? 4 pi square L divided by G minus what? 4 pi square Y divided by G. But you plotted a graph of t square against 4 pi against what? Y. So what you do is come here and say t square would be equal to minus 4 pi square Y divided by G plus, now we brought this to this side so that it will fit with the equation of what? A straight line. These are the silent points that you need to understand while you are solving graphs like this. The one that you plotted is the one that should come immediately after the, because this is a y-axis. your x-axis should come immediately after the equal to. So what did you plot in the x-axis? Was it not y? So anything carrying the y should come immediately after the equal to sign. That was why I brought this one here. And of course, you know that this one is carrying a negative sign, so the negative have to come with it this way. Then this one here is imaginary positive, which most times is not usually what? Real thing. So take this one to this side, it gives you plus 4 pi square L divided by G. Are you getting it now? Now you now compare with the equation of a straight line, which is y is equals to what? Ms plus c. So at the end of the day, your slope m, y is x-axis, so it means our m will be anything close to y. So our slope is anything close to y. So in this case, we can say that our m is equal to what? What is close to y in this first equation? Minus 4 pi square y divided by G. But in this experiment, were we asked to find G? No, we were not asked to find G, but you may just want to try to see if your slope is correct. So our m would be equal to minus 4 times, what is pi? 3.142 square. Okay, we are not supposed to write y because y is equals to s. 3.142 square divided by what? G. What is m as calculated? We said m is 0.04 seconds square. So we say 0.04 seconds square per meter, or 0.04 is equal to, now 3.142 square is what? 9.8, then times 4, 39.4384. Then you know, of course, this one is what? G times, because if G multiply this, it's going to give you this. Okay, now to get G, what do? Divide both sides by 0.04. When 0.04 cancel this, your G will be equal to, divide this and tell me what you get. 0.04, and this gives us exactly 985.96. So this is our G. G is equals to, when you take this one 1, 2, it gives you 9.85 meter per second square, or you can write G as the normal way, which is 985.96 centimeter per second square. So whichever one you want to write, meter per second or centimeter per second, it gives you the value of G. Now the next question here says that is derive the relationship between s and y, and between s, okay, derive the relationship between t square and y, and relate s and c with the physical constant. Now when they say s, what are they talking about? Now s is the slope. Are we getting it? S is the slope. When we related s with the physical constant, what physical constant does the slope carry? Is it not g, which acceleration due to gravity is a constant, and g gave us 985.96. now the next one is c, which is the intercept. Now we said c is what? From the graph, or from the equation of a straight line, c is the intercept, and it has value of 4 pi square L over G. So we come here and say this is equals to 4 pi square L over G. We've calculated our G as what? 9.85 meter per second, or 985 meter per second, whichever one we want to use. 985.96 centimeter per second square. So let's use that one since our values are in centimeter. So this gives us C will be equals to 4 pi square times L divided by 985.96. Now if you use this, it means we are using what? Centimeter per second square. What is your C intercept? The C is the intercept, which we got as what? 4.25. So we come here and say this is 4.25 is equals to 4 pi. 4 pi is what? 3.142 square times L, which is what you are looking for, divided by 985.96 centimeter per second square. Now at the end of the day, what are you going to have? You multiply this with this, and then it's going to give you 4.25 times 985.96 is equal to 4 times now 3.142 square is 9.872 times L, and then when you multiply 4.25 times 985.96, it gave me 4,119.33, which equals to, when you multiply 4 times 9.872, 4 times 9.872, that gave me 39.488 times L. 39.488. When this cancel this, your L will be equal to 4190.33 divided by 39.488. It gave 106.0. So this is the length L at the point at which it intercepted. The length L, okay, 106. But I don't really think there is any need to calculate this because we don't state it. So just relate it. Okay, we've related it, so I believe that it's correct like that. You should write it also, but I haven't seen many people wrote this before. So that is that. So the physical constancies here are what? L, which is 106.0, and then you have your slope as what? Your G as 985 centimeter per second square. Okay, now if you want to convert this one to, what is it called? If you want to convert this to meter, what do? Divide it by 100. So when you divide this by 100, it gives you 1.06 meter. Why this will be what? 9.85 meter per second square. So that is the solution to that question. Now the next question here is, state any necessary precaution you took to ascertain accuracy of your readings. Now one of the precaution is that it was ensured that your setup, or let's leave that, all those ones are things that you should copy from your friends. You take them, because we didn't do the experiment. I only have table here, so it will not be too nice talking about precaution here. Maybe you should copy these ones. Now explain how this setup can be used. Of course, everybody knows that one of the precautions is that error due to parallax is avoided. Then another thing is that zero error of meter rule is avoided in such a way that when you are taking your measurements, you put your meter rule where at the 0 point. So zero error, it was ensured that the zero error of meter rule was what? Avoided. Or say, state any necessary precaution. Okay, so that is that. And another thing is that your stopwatch was started when the experiment, or when the pendulum started. Are we getting? When the oscillation started, you start your stopwatch as at when the pendulum started, or when the bulb started moving to and fro. So all those ones, they are precautions that you took to ensure accuracy of reading. Another thing is that you make sure that the environment is airtight to prevent wind, because if there is wind, it will disturb the oscillation of the bulb. Okay, now it said explain how this setup can be used to determine the value of G, limitations if any. Now this setup can be used to ascertain the value of G by calculating the slope. First of all, by calculating the slope, which in this case is what? 0.04, and then equating the slope to the equation, which is what? M is, I think what was the something we took here. The calculation we did for the slope, okay, which is m is equals to minus 4 pi square over g. Minus 4 pi square over g. From here, from this, the value of the slope can be calculated. The value of the slope can be calculated. Okay, now the next thing is what other thing again that the question asks? Any limitation? There is no limitation with this experiment. No limitations. No limitations. Okay, there are no limitations. And then finally, conclusion. So in your conclusive or in your conclusion, what you are going to say is the graph is an inverse graph with a negative slope. With a negative slope measured to be minus 0.04 second square per centimeter. That is, I think, the conclusion. Or you could go further. That is the conclusion. That is the conclusion of the experiment. Okay, so that is basically all for M2 experiment. Everything you need to do is what I've given to you now. Okay, you start from here. Now note that most of the values here will differ from individual. You must not copy what is on the board or what is on the screen here. I just showed you how to go about your experiment. I believe in this experiment you are not asked to calculate for anything like standard whatever, standard error also. So that is everything for this experiment. Okay, thank you.